welcome back to part 2. So the next thing that we have to cover is, in order to complete the lab report, we have to fill in the tables that are within the text. So at this point, we'll start with table 40.1. And the first thing we have to fill in is the population density at each time. Now, they tell us in the reading that the population is going to double every half an hour. So all we have to do to fill in this table then would be to multiply the number of bacteria at each previous time by 2 to fill in the next line. And the chart stops at 4 hours, but they're going to ask you to graph things for up to 6 hours. So I'm going to complete those as well. The next thing we have to fill in is the growth rate. And the growth rate is a formula of delta N over delta T equals the growth rate. Now, delta is a Greek letter, and in science, it's usually used to mean the change in something that you've measured, or you might phrase that as the difference between two measured results with respect to some other variable. So in this case, N is the population, N for number, usually number of individuals. Here we're going to say number of bacteria, but so N is the population, T is time, that one makes sense, and delta just means change in. So when we say change in population, delta N, what we mean is it's the N at a certain time, we'll call that T1, time 1, minus N at T0. Or it could be at T2 minus T1 or T3 minus T2. It's always going to be the current time minus the previous time. And then delta T is going to be the actual time difference. Now here it's easy for us because the time difference is not minutes and hours on a clock, but rather total time. So what we're going to have for our N1 is going to be 20. And we're going to have for our N0 is 10, because at the first half hour mark, we've got a population of 20. We originally had a population of 10. And then this is all divided by the difference between a half an hour and the start. So that's still just a half an hour. And we have to remember that these are given in units of times 10 to the 3. So then when we multiply that out, we're going to end up with a difference between 20 times 10 to the 3 minus 10 times 10 to the 3. That's going to give us a difference of 10 times 10 to the 3, simply because 20 minus 10 is 10, and this is a like factor. And that's still going to be over 0.5. And then we can simplify that to a whole number, and that gives us 20,000. And if we're putting that back in the format of using the factor of times 10 to the 3, that is 20 times 10 to the 3. So that's what goes in the first line in the chart there, growth rate for the half-hour time. So we'll do the next one. And what I want you to do is pause the video and try the next one on your own, and then watch and see if you get it right. So pause it here. Okay, so did you get it right? One of the things that you might have passed over is that because all of our time steps are a half an hour, the difference between all of our times is going to stay 0.5 in the denominator. If we hadn't had regular time intervals, that might have changed. But since it's not changing with each piece of data we're given, then that's not going to change either. The next chart that we need to do is table 40.2. Now the math for filling in the growth rate is going to be the same formula, the same procedure. The only difference is that the numbers that are going to go in the numerator are on the top of the fraction are going to be the ones that are in table 40.2 instead of table 40.1. So you might notice that they start out quite similar, but when you get to the 2-hour mark, the pattern is broken. So just keep aware of that when you are filling in table 40.2, you want to use the data that's actually in that same table.